Hello and welcome to section 4.6. We're going to be talking about Newman projections in this chapter. These are an important class of um, ways of looking at molecules, physically looking at molecules and imagining their conformational energy and dynamics in solution. So the first thing to think about with the Newman projections is not a Newman projection at all. It's actually ethane. Let's draw this in blue. So let's use butane actually. So this is the bond line structure of butane, but what we're interested in is actually the wedge dash structure of butane, which I'll draw here. So if you remember, the wedge means something is coming out at you, and the dash means going into the board into the screen. There we go. So now two hydrogens are coming out at you physically, and two hydrogens are going into the board, and each of those four carbons are kind of in the plane of the screen here. And a Newman projection is important because we can take this wedge dash structure, and we can view it along this carbon bond here, carbon-carbon bond, to try and understand the steric or the steric issues that impact the conformation of this molecule. Okay, so sterics is just a word that means like how much physical space is present and how much physical space is being infringed upon in each molecule. So if something has a lot of steric issues or something has a large steric factor, it means that there are very large parts of the molecule that are perhaps bumping into other parts and influencing how the molecule wants to exist. Um, Kind of like how if you're ever in like a cramped elevator or well, it's COVID, so it's not like we can ever do that anyway. But if you're ever in a tight space, then you kind of have to just move your body in such a way that you can get into the space for a temporary amount of time. That's kind of the idea of sterics. And in this Newman projection, what we can do is we can imagine that we are an observer at this molecule, and our eye is kind of placed here, and we're going to view this molecule right down that carbon-carbon bond there. And so to draw that, we imagine that this circle is kind of like the area right around the carbon, and then we draw each of the substituents on that carbon. So up here first is the CH3, and then you have down here the hydrogen on the dash, and here is the hydrogen on the wedge. All right, but then there are also things in the back, right? Um, Another carbon and two hydrogens, and we can show those just as easily. There's the one on the dash, and there's the one on the wedge. I'm going to draw this one more time, and this time I'm going to color code each of the substituents, so hopefully you can see where they originated. So here's our butane. Let's use a different molecule this time. So this time it's going to be, we'll put a chlorine here. I said I was going to color code them. So we'll draw the structure first. Okay, so here's a chlorine in blue. And we'll keep this CH3 in blue as well. All right. And then we have maybe a CH3 down here in green and a hydrogen here in green. And then in red, we have in OH there, and here we have a hydrogen. All right, so now it's time to draw our Newman structure, imagining that once again, we're an observer, and we are looking at this molecule right down that carbon. So let's have a look here. Here's our Newman projection with the carbon in the middle. And so now we had the chlorine going up. We had the CH3 on the right side here, if we're imagining once again that we're looking down this carbon, right? And the hydrogen is coming out to the left. I don't like that pen width. There we are. All right, and similarly, in the back, we had a hydrogen over here and an OH back here. And last, we had the CH3 coming here. So this is how you draw Newman projections. And this has been section 4.6.